In this last example on letter C, it's the same type of question. We still are trying to neutralize our sodium hydroxide, but this time we're neutralizing it with acetic acid, and we would make sodium acetate plus H2O, the cation and the anion. By the way, this salt, that's the salt that's on salt and vinegar chips, sodium acetate. Makes sense that it comes from acetic acid, which is vinegar. Okay, so we still know that we have 50.00 milliliters of 0.200 molar sodium hydroxide, which we already calculated is 0.0100 moles of sodium hydroxide. This balanced chemical reaction shows that you need 1 mole of acetic acid for every 1 mole of sodium hydroxide. So if you run your stoichiometry equation, just like we did for the nitric acid and the HCl above that, you're going to find that you need 0.0100 moles. And the problem tells us that it's a 0.200 molar solution that was given. And so we're looking for the volume. And we know that the number of moles is equal to molarity times volume. So volume equals N over M. And in this case, we're going to end up with exactly the same. We have moles per liter, and so that is going to be 0.0500, which is 50.0 milliliters. Now that makes sense because look at this reaction. It's 1 to 1. They're both the same strength, so they both need 50 milliliters. And remember, anytime we use acetic acid, HC2H3O2, these H's, those aren't the ionic part. This is going to break down to the H plus, and the acetate ion stays together. That's what's going on. So this H plus is going to react with this OH. And the net ionic reaction, if you were to write this out, looks like this. We take a H plus and an OH minus, and we make water. Make water liquid, I should say. Okay, that's it for that one.